Hello and welcome to my presentation on security evaluation of dual stack systems. My name is Patrick Fehrenbach. I work as a security researcher for ERNRW, but mainly focusing on web apps. So IPv6 is not really my thing, or wasn't my thing until, said, oh, well, you could do a thesis on IPv6, and then I went on and actually thought about what I could write on, and this came out. I wrote this at Hochschule Furtwangen University with my first supervisor, Professor Dr. Friedbert Kaspert, who can't be here actually, and Christopher Scheuring of ERNRW. So, first of all, a little disclaimer on this all. There will be a lot of numbers, a lot of charts, and a lot of figures. So if you are at one point lost in my presentation, just interrupt me and I'm trying to explain what was the intention about it. Also, as with every data, they could be wrong, but I think, or I hope I did my best, so they are not. But there's always the possibility that I switch something around. The roadmap. First of all, I want to talk a little bit about dual stack. Nothing too technical, just the idea behind dual stacking. A bit about motivation of my research. Previous work will also be done. And of course, the results of my research and conclusion. So let's start with dual stack. Who of you have already implemented a dual stack on any system? Quite a few, nice. So, well, this is the concept. You have a server. It can either way have an IPv4 address or an IPv6 address, which is pretty straightforward. Since I'm in security, I thought about, well, what could be the security issues while doing such a... if you look, or if you search for security in terms of dual stack, you won't find many things. The one thing I found was the following RFC. RFC 7381, the Enterprise IPv6 Deployment Guidelines, which I highly recommend to read. Actually, really, really good. So it clearly... It is? Oh, really, really good one. So it says that it should be noted that in dual stack networks, the security implementations for both IPv4 and IPv6 needs to be considered. Well, this is an important fact. You both, you not only have to do it for IPv4, but for IPv6 as well. If you read further in the document, it will specify it a little bit more. As you can see, as it stated, that all routers and hosts operating in a dual stack environment with both protocols families enabled must have a congruent security policy for both protocols. Again, both protocols. Yeah. Well, while reading this, there was just one question in my mind. I'm in security. What if they haven't? So, think about it. What if they haven't? What could possibly go wrong? We're in security. We always think about, or we always try to raise the question, what if they haven't? Right? There's a slightly good possibility that they haven't done it. So, an attack scenario, as I thought about it, could look like this. You have a server on the left side, and the server offers some services on port 80, 44, 8080, 22, 23, and so on. The server is performing dual stack, and for the IPv4 address, there are firewall rules which only permit, or which only allow 80 and 44.3 and permit all the other ones. So while there is no firewall for IPv6, it could look like this. Imagine you are a malicious hacker and you find a server like this. So what an hacker normally is doing it's performing a port scan to see what's on the server. So what can I attack? If it does a port scan on IPv4, it will obviously only get back port 80 and 44.3. But if he does the same thing on IPv6, he will get a lot more ports, a lot more attack surface, like things he can attack. And well, this is a pretty serious security risk, isn't it? So in my next step, I thought about, well, this is just an assumption. How can I prove it? So my task for my thesis was, I thought about writing a script that actually finds out if the server is dual stacked. And the script also needs to check which ports are open on which protocol. The second thing I thought about was getting a list of domains, of suitable domains, so I have a large number of hosts I can analyze. Of course, to scan them, to store them, and the last step, to analyze them. So, getting a list of suitable targets. The first idea I had was to get the list of the Alexa top 1 million domains. Those of you who are not familiar about it, the Alexa always rates the sites on their visitors, so those are the 1 million most visited sites. Why have I chosen them? Because they're frequently used, right? They are the most visited website worldwide. They are well maintained, hopefully, or they should be well maintained. A lot of users. Yeah. And they're in CSV file format, so I could easily use them for my script. So let's sum it up. What I'm going to do is, I want to identify all the dual stack domains on the top 1 million Alexa domains. I want to perform a full TCP port scan on all ports, on both protocols, IPv4 and IPv6. What I additionally did was to perform some version detection to see what's actually on the port, some product detection, some product detection to see what's on the port, and version detection to see what version of the product is running on it, because it's interesting. Yeah, please. There will be. No, there will be a slide that will explain it. It will be in slides. It did. Good thing about the procedure of how the script worked. As an input, it got the domain. The scanner then used the socket.getAddressInfo of Python, identified if it has an IPv6 address and IPv4 address, and if this matches, so both of them are there, then Nmap started to do a port scan, the IPv6 address and the IPv4 address, and everything is then stored in the database. So, there it is. Ethical considerations. I have, or we have, if I talk about we, it's me, my professor, and so for sharing, we have responded to every abuse mail we've got. For every provider that sent out an abuse mail, we took care of it, and we removed the data out of our database. with the full /48 Yeah, sure, sure. Well, once you're on Alexa, the service that you have for is or not. Say, there was a part of the equation which is not there, but sorry. No problem. So just one word about my university. I could have done it there. I had the full backup of my university, so I had every permission to do it from their side. But actually, they don't have IPv6. And tunnel broking was not possible due to some firewall or whatever. So yeah, I did it on a cloud-based provider. Maybe one thing about the abuse mails, I got about 5 to 10, which is pretty less, I think. And what was also fascinating about it, they were only complaining about IPv4 traffic. They haven't even mentioned IPv6 address in any abuse. So maybe they're not monitoring it or they're not responding. There's another thing, we only use RFC compliant SYNAC packets. So none real packets were sent to bypass any firewalls or anything. So everything like this. Of course, we believe this research contributes to IPv6 security. That's why I've wanted to do it. That's why I've done it. And of course, we want to make the world a safer place, don't we? So without further ado, I want to present you my results. I was able to identify 75,000 domains, which dual stack enabled, sums up to 140,000 IP addresses, IPv4 and IPv6, and about 976,000 open ports on both IPv4 and IPv6. For statistical reasons, I have excluded in my research port 80 and 44.3 because they are the most visited websites worldwide. Those are intended to be open. Yes, I did this on both protocols, and as you can see in the chart right here, so the gray area is IPv4 ports found, and the green area is IPv6 ports found. What would you expect, or in your environment, how does it look like on a dual stack host? So, as you can see, there might be some discrepancies, right? If you think about it, there should be a parity in ports. Like you should have the same ports on IPv4 you have on IPv6, right? Because everything else would be a little bit weird. So I looked at the parity actually. So what you can see in this pie chart here, you find a one-to-one parity of IPv4 and IPv6 on 38%. But you find you find different numbers in 62% of the overall 75,000 hosts, which means one or more port is different from each protocol. So in my next step, I looked at how do the ports differ. Are they more open on IPv6 to IPv4 or from IPv4 to IPv6? That's interesting to know. This one I have to explain a little bit more because it would be confusing and I don't think you can see the gray area, right? No. Wait a second, just switch it to black. Yeah? Oh, I just switched it to black. Gray wasn't the best choice. No, sorry, it doesn't work, but I will show it. I can see it here, so I'm going to show you how long it is. So on the left side, you can see the divine amount of ports, meaning 1, 2, 3, 4, or 5, or 6 ports have been found more on IPv4 or on IPv6. So gray area is like about here, I think, for IPv4. So in about 20,000 cases, you could find more open ports in the IPv4 address than on the IPv6 address. And in only 2,500 cases, you could find the other way around from IPv6 to IPv4. So everything green is where IPv6 has more open ports than IPv4, and everything gray, yeah, the other way around. So, what's also interesting about my research is I looked at the IPv6 addresses I found, and most of them had like a structure. And while I was analyzing them, it turns out that about 40% of them, or of the found IPv6 addresses, belong to Cloudflare. Who of you doesn't know Cloudflare? Cloudflare is a content delivery network which should protect your website and assigns you an IPv4 address and automatically an IPv6 address. So 40% of them are only open on web ports, 80, 44.3, and 8080, because Cloudflare, if you use it, they don't allow anything else. So it's pretty good. And yeah, as a result of this, I excluded them additionally from my statistics. So the next thing I want to step in is the most found ports, like on each protocol I've found. If we first look on IPv6, I was able to identify those 10 ports, like 22, mostly used for SSH, 21 for FTP, and the following ones for the mail protocols, except 81, which I haven't heard of before that this is used. But it turned out that on IPv6, actually, it was ranked 5. While looking at the hosts I found on port 81, it turned out to be some kind of development environment for HTTP. So this is commonly open, and I don't know why. So on rank 10, it is DNS. What's interesting about it, if you sum it up, 47% of all the ports, so almost half the ports I found on IPv6 were among the 10 most found ports. Always think about 80 and 44.3 are excluded because otherwise they would break the statistics. So, but apart from that, 50% are found among the top 10 ports on IPv6. So, I did the same thing, of course, on IPv4, and I was able to identify that 843 was the most used port after 80 and 44.3, of course. Followed by the same protocols as IPv6, sorry, with also the mail protocols here. But in addition, I found out on place 10, port 3306. Anybody of you know what's running on it? Correctly, MySQL. I was able to identify 4,293 instances of MySQL, and as some of you might know, MySQL by default is only listening on the local host. So it was their intention to publish their MySQL to the public for whatever reason. So after looking at what was most used, I thought about, well, it would be interesting what is most target, right? So I found this really interesting statistics by Akami Technologies, also a content delivery network. And it turned out that Telnet has the most global attack traffic. So followed by Microsoft, 8080, port 80, yeah, so on. And you can identify really quickly MySQL here, SSH there, and Telnet there, and we all have those ports in our database. And yeah, they shouldn't be, or as I think, they shouldn't be that open as I found them to be open. So if we took this most targeted ports, combine it with my research, it turned out to look like this. There it goes. The gray one works. Weird, because I used the same gray here than on the other slide, so sorry about that. So as you can see, overall, you have more IPv4 ports open than any IPv6. I wasn't actually able to identify any host that had more ports open on IPv6 than on IPv4, which I think is a good sign. So while these few are pretty equal to each other, you can quickly identify that those one are not. You look here at port 23, mostly used for Telnet. I was able to identify 549 Telnet services, don't say Telnet services because it's port 23, but they don't have to be there, but most of the times they are there. Which summed up in about, in IPv6, I only found about 29, which is a huge difference, as I think. So the same one with any other protocol. You could say, or that was one assumption I had, which is pretty critical to say, but you could say the attack surface on those dual stack domains is on more risk if you scan the IPv4 address than the IPv6 address. And as I said before, or what was my intentional thinking about it, I thought it would be the other way around. And I thought it would be a complete mess on IPv6, but it turned out not to be. So some percentages of the risky ports. Port 88, almost the same on both ports. 80 without Cloudflare, because Cloudflare is automatically enabling port 8080. Yeah, 0 point something. SSH is almost as much open on IPv6 than on IPv4. MySQL, yeah, like I said, a lot more open on IPv4 than on IPv6. And yeah, to just look at the numbers, IPv6 seems to have more intense port rules than IPv4 has, just by looking at the numbers. So as you could see here, there was quite a high number of Telnet, and I was actually, I was surprised to see any Telnet in the Alexa top 1 million, because who is using Telnet on a public IP address, right? Some of you is using Telnet on a public? Yeah, it's weird, right? So in the next step, I looked at the Telnet I found a little bit more closely. Those were the ones I was able to identify as actual Telnet services on IPv6. Only a few. And I wasn't trying to access them because I don't want it to violate any privacy or anything. So I just can show you that I have found those on IPv6, and this list including 500 more on IPv4. I think Nmap is using some kind of fingerprint detection on the port and matches it to a database, and was able to identify those. There were some that Telnet didn't identify the first try, so I gave it another try manually, and I looked at them, I looked at them a bit more closely, tried to increase the detection rate of Nmap. It turned out they all are Telnet ports on IPv4. So, what I did next, as I can see here, MySQL, the number is just incredibly high, as I think. So I went on and tried to identify, well, are there other SQL servers somewhere in my database to see how frequently they are used on each protocol. It turns out that MySQL was the most used SQL server, followed by Postgres SQL server, which was also frequently used. But I wasn't able to identify any Microsoft SQL server at all. About 5 on IPv4 and 4 on IPv6. Very, very few. But since MySQL was that frequently used, I had to look at the versions I found. Like I told you before, I don't only have collected the product, but also the version, because the version also tells us a bit about how good is the patch level, right? If you're an attacker and you find an outdated systems, you're more likely to have one than on a fully patched system. Just looking at the numbers, let's just explain this here. Well, it's a little bit small and not easy to read, but actually this one is the scale for the product version of MySQL. And those are in no further development, so they stopped the support for those versions, and those are still maintained. Everything I pointed out here is in no further development, so meaning that there will no updates before it, and yeah, those are highly outdated. On the other hand, I wasn't able to identify any outdated MySQL or that outdated MySQL on IPv6. So I had no direct conclusion, just maybe a conclusion that if you are running IPv6 in your server, you look that you are patched. Right? No? Yeah. So, well, it looked pretty stable. Yeah, sure. Yeah. It is? For what reason? what reason? I mean, okay. Okay. Oh, that's interesting. It's a good point because I was totally surprised because why? No, normally you only use it because if you want to insert data from a different public IP address to it, and mostly you've done it on your machinist, and yeah, so whatever. The next thing I did was to have a closer look on the SSH servers I found, because as you saw in the other slide, SSH is the most used port on IPv6 and the second most used port on IPv4. So OpenSSH is the most used SSH servers on both IPv4 and IPv6. The WRT45 modified drop beer SSHD, I'm not sure if Nmap was able to identify that correctly, but it seems about correct. The same, followed by some SSH system I've never heard before. Someone of you did? Like, we only do SSHD? No. So, me neither. Or Van Dyke vShell. So anyways, this was the result on the SSH servers. As on the SSH servers, as on the MySQL servers, I did the same version and product detection on the SSH servers too. So as you can see here, the green one is always IPv6. And the gray one, gray because it's old, is IPv4. You see, you won't find much difference in those versions. You find a huge difference in those versions. Well, in SSH it's a bit difficult to say that it's outdated from my experience because they've backported patches for critical things. But it turns out to be that SSH doesn't look that bad than MySQL did. So, as you can see here on the numbers, or on the chart, you slightly could think that those servers running SSH, those are the same, because they have a parity in the versions, right? Well, I found this pretty interesting to see which versions they are running and there's here such a difference. So, well, that was everything about the port side. Now, I have some recommendations for you. Always check both protocols, IPv4 and IPv6. There's always the chance that some mistakes were made in firewall rules. You can actually check yourself using our script, which will soon be on GitHub. And well, it depends on what you want. That script will perform a full TCP scan of all available ports. It will identify the version it found on the port. It will find the product on the port. It will insert it if you tell it to do so in a database. You can, I don't know, if you have a large network, you can look it up later. Yeah, it also performs. Yeah, yeah, sure, sorry.
So you did it by the same script, isn't it?
Yeah, sorry.
So the wrapper on Nmap for
it's a little bit different. It's actually pretty fast because it has multiprocessing enabled. So you can run about 5,000, depending on your resources, parallel scans. Well, be careful, CMAP can only scan a range, and it can only scan for one given port. You can tell ZenMap or any of those scanners to scan all the ports. So it will only identify you really quickly one port. I thought about using it too, but then I turned out to be, or then I said, okay, Nmap is more reliable than ZMap because what? Sorry.
Was the development of ZMap introduced?
Was it mask scan? Yeah, yeah. I tried. Actually, I did a lot of research which one would be the best suitable. They turn out to be very unreliable. So on the one run, you identify this port, and on the other one, didn't identify it. So maybe it could be it wasn't the right environment I was choosing. So well, anyways, Nmap turned out to be the good one for me or for my research. Yes, and what you additionally should check is, do your devices support IPv6? If your firewall does not support IPv6, it won't care about any IPv6 traffic, which is obviously. So, my conclusions. As I could find out on the Alexa top 1 million most visited website worldwide on the dual stack, IPv4 ports are about 6 times more open as they are in IPv4.
And then it's compared total amount of IP addresses compared to open ports from percent. So that's not total 1 million.
No. It's just the dual stack.
Those who
It's just the dual stack, the 75,000 dual stack, and the 970,000 ports I was identified were identified on those. And yeah. Yeah, what's also I thought was interesting is 40% of them are belonging to the Cloudflare content delivery network, which is pretty interesting because they do because they enable IPv6 per default, and they seem to be doing a good job by only allowing 80 and 44.3. And what you could also say is there is a higher patch level of MySQL on IPv6, maybe just because of the reason MySQL only introduced IPv6 about 4 years ago. So any version older than that is not even using IPv6. Potentially vulnerable ports are more likely to find on IPv4, which I showed you in the other slide. And as I would say, IPv6 is there, and I think you should use it. Because from what we saw here, what the top most visited websites did was a good job. I kind of would say there is more a problem in IPv4 than in IPv6 because, yeah, most of them did a good job in IPv6, but not in IPv4. It's weird. Because maybe on IPv6, they rethought what should be public and what shouldn't. One last thing I should mention. During my research in December last year, a talk was published by Mark Ellman. And he was actually doing the same thing as I did. It was...
Like you welcome stuff and then your paper is published there. Oh. Maybe
Yeah, so Enno sent... Yeah, it was actually 2 months before. So Enno sent me an email late night and asked me, hey, when did you hand in your thesis? So, but yeah, well, Mark Ellman did a great paper on the same topic as I did, but he didn't focus on the Alexa top 1 million, that he didn't. But he focused on servers based on DNS records he found. So he analyzed about 570,000 hosts or servers and about 80,000 routers. And he was able to identify large discrepancies between v6 and v6 services reachability, which is pretty interesting because I had the other way around. results. And what also should be mentioned, he only focused on very tier ports. I think it was about 8, but I'm not entirely sure. So he only scanned for 8 services on those. And he was able to identify that V4 did a better job than V6. Actually, the other way around, I did. So it was pretty good for me, actually, that he did this in December for my thesis, because then I had the perfect paper to compare my work. Sure.
University of Berkeley did research and
Think?
whatever. Sites were IP address.
Maybe he's from Berkeley. Could it be? So it was he and him and his team. Yeah. Well, it's the same. Oh, thank God. Thank God. Mannhauser Mark. Yeah. I talked about him a lot about this topic.
So he did a similar research that in one of the conferences in 2012, and he.
Okay. Yeah. Well, the biggest difference was from IDA than he did. He chose 570,000 completely random posts, right? And was able to identify the exact difference from what I did. And I wanted to focus actually on the well-visited websites, because most of the time people are not aware of security if they are unaware of what security could damage. And well, maybe they identified services or servers that are, well, how to say it politely, that are not well maintained. But it's just an assumption of me. So I come to an end. All the slides, all the graphs and charts and bars will be available at insinuator.net. If you want to, you can follow me on Twitter. I'd appreciate that. And yeah, I think we have time for questions.